All right, we're on number 4. So number 4, we got dy dx is equal to negative x over y e to the x squared. Your initial condition I'm going to give you is y of 0 is equal to 2. All right, so now that we're on example 4, if you want to go ahead and try and separate the variables on your own, go ahead and hit pause. Separate the variables, make the y's with the dy and the x's with the dx's, and we'll get started. All right, so to get the y's with the dy, I have to multiply this y over here. It's kind of like I'm cross-multiplying, but I'm not going to cross-multiply this because it's an x. I'm just going to leave it right there. So I'm going to multiply the y over here. I'm going to multiply the dx over here. I get y dy is equal to negative x over e to the x squared dx. So now I have all my y's on the left with the dy. I have all my x's on the right with the dx. I'm going to go ahead and integrate both sides. So the integration of y is going to be a y squared over 2. Now, over here, when I'm integrating that, I have to try and figure out what to do. And I'm looking at perhaps doing a u substitution down here. But remember, we've actually seen a problem that looks like this. And if we do a u substitution with it down there, we're going to end up with something that looks like this. And I can't integrate, even if that goes away, I can't integrate an e to the u when it's on the bottom. So what we did before, and we actually were in class when we did this and we saw this problem, we brought this to the top. So we're actually integrating negative x e to the negative x squared dx. Because when we brought this to the top, we were able to make this u, and then we were able to integrate e to the u. So u is equal to negative x squared. Du dx is equal to negative 2x. And we're going to integrate a negative x e to the u du over negative 2x. So the negative and the x cancel, and you're actually integrating 1/2 e to the u du. So that becomes a 1/2 e to the u, which is a negative x squared, plus c. Now, I did give you an initial condition, so we're going to go ahead and plug in that initial condition. So our initial condition, our x was equal to 0, our y was equal to 2. So 2 squared over 2. So 2 squared over 2 equals a 1/2 e to the negative 0 squared plus c. That's just going to be a 1. This, 2 squared is 4 divided by 2, so that's 2 is equal to a 1/2 plus c. So 2 minus 1/2, 2 minus a 1/2 equals c. So we have 4 over 2, that's a 4 over 2, so that c is equal to 3 over 2. Okay, so I take this and I'm going to plug it back into the equation that I started to substitute for. So I end up with y squared over 2 equals 1/2 e to the negative x squared plus 3/2. I want to solve for y, so I'm going to multiply the entire equation by 2. So it's e to the negative x squared plus 3, because basically it just cancels out my whole denominator. And then I'm going to square root both sides. Now, I checked to see if it's plus or minus. My initial condition was y of 0 equals a positive 2, which means my answer is going to be a positive value. So I have y is equal to the positive square root of e to the negative x squared plus 3. Final answer. Any questions on number 4? Yeah. If you did, send me an email. Number 5. Just a habit for me to say that. 22 years of asking, and now I'm teaching online. All right, number 5. So we're going to start off with dy dx is equal to y over x. Now with this one, when we cross multiply, we end up with x dy is equal to y dx. Well, that's not right, because I want the x over here with my dx, I want the y over here with my dy, so I'm going to divide both sides by both of them. So I get dy over y is equal to dx over x. Now my y is with my dy, my x is with my dx. So now when I integrate both sides, I get ln of y is equal to ln of x plus c. Now, look at this ln. Because we have the ln, we know we're going to have that big C going on. And I'll walk you through it again, but I'll also let you know that you can just go straight to the big C once you get used to doing them over and over and over again. Okay? Notice I didn't give you an initial condition. We will have one. It's coming near the end. So, ln can be log base e of y is equal to all of this. Now, I'm not going to change that to log base e because it's not part of my log loop. So, my log loop, e to all that stuff equals y. So, e to the ln of x plus c is equal to y. Now, when I simplify this, let me go over here and simplify this. This is e to the ln of x times e to the c is equal to y. Now remember, e to the c is just some big c, some big constant. We don't know what it is. And e to the ln of x is just x. So we end up with our answer being big C times x equals y. Okay? So again, I walked you through. Now, you can do this in your head. You don't have to write down all these steps. So you can go ahead and say, okay, I know that this is going to have an e. E to all this stuff is going to equal y. You also know that this is just going to become a big C in the front. So after you do it a couple of times, you're just going to go straight to big C, and then you probably would write e to the ln x before you switch it over to x. But as many steps as you need to write is fine, but just know that you don't necessarily have to. It's okay just to jump right there. Okay? All right, so looking at number 6. Number 6, we have 1 plus x to the 4th dy dx is equal to x cubed over y. All right, so go ahead and see if you can separate the variables. Hit pause. All right, so to separate my variables, I'm going to do this in 2 steps. Again, if you can do it in your head and you can rearrange all of the things in your head, that's fine. But please do not feel bad if you have to go step by step in order to rearrange your variables. So let's go ahead and multiply y times 1 plus x to the 4th dy is equal to x cubed dx. Now, I got my y with my dy, I got my x with my dx, but I got this right here that I got to then move over. So I'm going to do that by dividing. So I'm going to get y dy is equal to x cubed divided by the 1 plus x to the 4th dx. So now I have all my y's with my y's, all my x's with my x's. I also, if you're going to go ahead and try this problem on your own, I'm going to give you an initial condition of y of 0 equals 2. So now that you've got your variables separated and you've got your initial condition, if you want to hit pause again and see if you can come up with a final answer, that would be great. All right, so we have to integrate both sides. So y integrated is y squared over 2 equals. Now over here, we've got a u sub, okay? U substitution. So I'm going to kind of do this over here to the side. U is 1 plus x to the 4th. Du dx is equal to 4x cubed. So I'm integrating x cubed over u times du over 4x cubed. Okay? My x cubes cancel. And I've got 1/4 the integration of 1 over u, which is going to be 1/4 ln of u. So I get 1/4 ln of my u plus c. Okay? Now, I need to solve for c. So, this is your x, this is your y. You're going to plug it in now and then solve for your y. You could multiply the whole thing by 2. It just gets a little confusing though, because is that going to be a 2c or is that just going to be a c? So my advice is to plug it in now. And once you plug it in now, then you can solve for the y. Now, if you get some ln that you don't know the value of, you just leave it in terms of ln, and that's okay. Okay, it would just mean that your c would have an ln in it as well. So let's go ahead and see what happens when we plug things in. So we're going to plug in a 2 where we get the y. So that's 2 squared over 2 equals 1/4 ln of 1 plus 0 to the 4th plus c. Well, this is just ln of 0. It's just ln of 1, and ln of 1 is 0. So you end up getting 2 squared is 4 over 2 is 2 equals 0 plus c. So 2 is equal to your c. So now I can go ahead and I can plug it in, and I can say that 2 is equal to my c. So I've got right here y squared over 2 equals 1/4 ln of 1 plus x to the 4th plus 2. Okay? And so now I can go ahead and I can solve the rest of this. Multiply everything by 2. Be careful. When you're multiplying everything by 2, you aren't multiplying any of this stuff right here. You're not going inside this absolute value. You're not messing with anything past ln. It's kind of like if I gave you sine of 2x and I wanted you to multiply it by 2. You would just have 2 sine of 2x. You're not like distributing it in. So you're just really multiplying this 1/4. Because this 1/4 is being multiplied by this ln as well. So if you're multiplying that by 2, you're going to get 1/2. So y squared is equal to 1/2 ln of 1 plus x to the 4th plus 2. Oops, plus, we do have to multiply that by 2, so that'd be plus 4. Okay. Square root both sides, you have a positive value. So y is going to equal a positive square root of 1/2 ln of the absolute value of 1 plus x to the 4th plus 4. Now, had we not had this initial condition, everything would have been the same, except this would be a c. Now, when it's a c and you're multiplying the whole thing by 2, you don't need to write 2c. Because again, a constant is a constant and we don't know the value of it. So multiplying it by 2 isn't going to change the idea that we just don't know what it is. So again, go ahead and just leave it a c. Now, because we found c, we knew that it was a 2. So we could go ahead and multiply it by 2 to make it a 4. Okay. All right, number 7. We have e to the negative y sine x minus dy dx cosine squared x equals 0. That looks exciting. So I want you to go ahead and hit pause. Try and separate your variables. So your x's are with your dx, your y's are with your dy. So the first step I'm going to do is I'm going to move this over to the other side. So I have e to the negative y sine x is equal to dy dx cosine squared x. Okay, I added it over to the other side. Now, after I do that, I'm going to go ahead and divide by my cosine x and multiply by this. I'm going to get e to the negative y sine of x dx divided by cosine squared x equals dy. I'm going to go ahead to divide by this. So I'm going to just sort of cross it off there and divide by e to the negative y. Well, what's going to happen to that? That's going to come to the top. So I'm going to have sine x over cosine squared x dx is equal to e to the y dy. Now, it's okay that your y's are on the right and your x's are on the left. That's okay. You don't have to worry about that. Integrate both sides. You have a u sub going on right here. So, your u sub is cosine x. The derivative of cosine is negative sine. So we're integrating sine x over u squared times du over negative sine. So we have a negative integration of u to the negative 2 du. So that gives me, sorry, just looking at my paper here. That gives me negative u to the negative 1 over negative 1, or positive 1 over u. Positive 1 over u. So this becomes a positive 1 over u. So 1 over cosine x is going to be a secant. So I might just write secant x plus c is equal to the integration of e to the y is e to the y. Oops. Sorry, I was just going on down. Okay, so we need to solve for y. I did not give you an initial condition notice, so we need to solve for y. So we need to take the ln of both sides, because we need that to come out of the exponent. So we end up with the ln of secant x plus c equals ln e. That's just going to go away and give you y. Now, there was another way to integrate this over here. You could have broken this up and you could have written it a different way. Let me go ahead and show you down here. If it's just going to confuse you, go ahead and fast forward. But if you want to see it, it's actually interesting. I could break this up into sine x over cosine x times 1 over cosine x, which is tan x secant x. Okay? And if I have tan x secant x and I want to integrate that, well, that's just going to be, let's put a dx right there, that's just going to be secant x plus c. So I could have actually done it without my u substitution, and I believe we actually did a problem like this before we learned u substitution. Now, u substitution, as you look, it's fine and it works. Or if we'd memorized those trig functions and we knew how to separate and did that, if you see that and that's the way you want to do things, then that's fine as well. It's going to get you to the exact same answer. Okay? All right, moving on to number 8. We're almost done. 8 and 9. Number 8, we have dy dx is equal to negative the parentheses of 1 plus x times the parentheses of 1 plus y squared. And just kidding with my equal sign. Let's actually make this problem what it should be. Equals 0. So dy dx minus the parentheses of 1 plus x times the parentheses of 1 plus y squared equals 0. This one is a fun one. You're going to love it. Go ahead and separate your variables and then come on back. So I'm going to add both of these over to the other side. So dy dx is equal to a 1 plus x times a 1 plus y squared. So I'm going to multiply by the dx. I'm going to divide by the 1 plus y squared. So I get dy over a 1 plus y squared equals a 1 plus x dx. All right, integrate both sides. This is where you're going to struggle right here. Okay, when you try u substitution, it's not going to work. U is equal to 1 plus y squared. When you do du dy, you're going to get 2y. Well, 1 over u times du over 2y, you've got that extra y. You can't do that. Now remember, when we were learning integration, we started with integration without u sub, then we moved into integration with u sub. Our next thing that we learned, if it didn't work with u substitution, it was an inverse trig function. So you want to think, oh, inverse trig function. What are my inverse trig functions? I've got inverse sine, I've got inverse tan, and I have inverse secant. This one had the plus sign at the bottom. That reminded us of the t, so it was inverse tan. So this is just inverse tan of y. Now this over here, we can just go ahead and integrate. The integration of 1 is x, the integration of x is x squared over 2, and don't forget your plus c. Okay? Now, we need to solve for y. Well, all you have to do is flip-flop like the inverse thing. It's kind of like switching your x's and y's. When you switch your x and your y's, you're actually undoing the inverse. So if we switch our x's and y's and put all of this with the tangent, you're undoing the inverse, and so it'll just be the tangent of all this stuff equals y. So it's like I took all of this and this y and I switched their places. And by switching their places, I got to undo the inverse. Okay? So that's how you deal with inverse trig and how you get those variables outside of the inverse. Undo the inverse by switching your x's and y's again. All right, our last problem, number 9. Number 9, we got dy dt plus y is equal to 2. I'm going to give you an initial condition of y of 0 is equal to 1. So go ahead and get started with this one, but then come back to me before you plug in your initial condition. There's actually 2 ways that we can solve in our initial condition here. We're going to look at both of them. So separate your x's and y's and then come back to me. You can integrate and then come back. All right, so I'm going to subtract the y. dy dt is equal to 2 minus y, or you could have y minus negative y plus 2. So then I am going to multiply by dt, and I'm going to divide by the 2 minus y. Because I get dy is equal to 2 minus y dt. You can't just add that over because you don't know how to integrate y plus dy. So this has to go together, and see how these things are being multiplied and I had to put parentheses around that? I got to divide the whole thing. So I get dy divided by 2 minus y is equal to dt. Now I can integrate both sides. Now, when I'm integrating over here, my u is equal to 2 minus y. The reason I've got that is because the derivative is negative 1. So I'm actually looking at the integration of 1 over u times du over negative 1. So I have a negative ln of u. Okay? Is equal to, that's just going to be a t plus c. All right, now we're ready for plugging in. Now, because you've got this ln thing, and you've got this negative sign here, you've got a lot of stuff going on with this problem. So, you can do 2 things. You're going to have that big C. And you could solve for big C first and then get your answer, or you could start plugging things in now. Now, sometimes I encourage people to start plugging things in now, because if it works, then great. If it doesn't work, if you end up with something that's, ln of 5, and you're struggling to try and get the answer, and you didn't want it in terms of ln, you can always do the big C solve that way, and then plug in your x's and y values. So let's go ahead and deal with this one right now as we have it. So let's go ahead and plug things in. So this is going to be your t, and this is going to be your y. So you have negative ln of 2 minus 1 plus 0 plus, or sorry, equals 0 plus c. So that's negative of ln of 1 equals 0 plus c. Well, we find out that our c is just equal to 0, because this is 0. So this is just going to go away. It's not there. So we end up with negative ln of 2 minus y equals t plus 0. I'll show you the other way in a second. Now, I can't deal with that negative right there and do my log loop thing. And I don't want it as an exponent. It's going to be way easier if I divide it through. So if I divide it out, I've got the ln of 2 minus y is equal to a negative t. Now I can do my log loop thing. The log loop thing would be a little bit easier at this point in time. So I have e raised to the negative t is equal to a 2 minus y. So I'm going to subtract my 2 over, so e to the negative t minus 2 is equal to a negative y, and I'm going to divide that negative again. So I get negative e to the negative t plus 2 is equal to y. All right, so I've got to take a look at something that happened here, which is horrible to do on video. So we're going to go ahead and hit pause here for a minute. Let's see if that works.